Yeah, I just love doing this. What is going on, everybody, and welcome to a series of reinforcement learning tutorial. So let's just get started. Oh, yeah. So reinforcement learning, and today we're going to be learning the Q learning part of reinforcement learning. So what is reinforcement learning, or what is Q learning? You know, I just went ahead and just picked the definition right off the Google. So if you just go and Google what is Q learning, this is what you get. It's essentially, it's like a model free reinforcement learning. It's essentially an algorithm, right? So like you could think of it like a CNN or something of that sort, but this is model free in essence that you don't have to typically create and train the model before deploying it, right? So what happens there essentially is it will learn based on the the actions to be taken and all of that stuff. So essentially Q learning, I'm just going to read this out anyway, is a model free reinforcement learning algorithm, to learn a policy telling an agent. So yeah, so what is an agent? So agent is someone which performs some activities in a given environment. If you think of, let's say Super Mario or just Mario, the agent in that Mario is Mario itself, right? So he's the one who's performing some actions, taking actions, and all of those, and the actions are being taken based on the environment he's in, right? So right, so that is essentially the meaning of this, right? In essence, to say what action to take under what circumstances. So circumstances is essentially an environment, right? So yeah, and model free means it doesn't require any model of that particular environment, and it is, you can sort of make it robust enough so that it sort of figures out the way to deal and achieve the target. So for example, I would just want to show you the basic example of that, and I'm just going to create a new Python file, and then we Q learning .py, right? So I'm just going to ignore this, right? So I'm just going to import Jim. Oh, my bad. Yeah, and by the way, Jim is yeah, I'm just going to talk about it a little later, but yeah, that's essentially what it is, right? So I'm just going to import Jim, and I'm going to create an environment. It says Jim.make. Don't worry, you will know this. You'll know what exactly I'm up to, and yeah, I just want to show you an example, right? So Jim.make mountain card dash v naught, and I'm just going to reset the environment, so that everything starts fresh, right? And I'm just gonna start repeating, sort of until some while condition, right? So while not done, you just go ahead and I can take some random action in that. Actions equal to env dot action space dot sample. Oh, my bad. I don't know why it just did not. Dot sample. When you're so used to the predictions, you kind of feel that your coding is wrong, right? So kind of makes you feel like that. Right, so I'm just going to take some action, and I'm going to say env dot steps. Sorry, step is the actions I pass, and just take some random actions, and env dot render. Right, so I'm just gonna go ahead and run this file. Yeah, so you can see what's going on here, right? So essentially you can think of this, you, whatever you want to call this, as the agent who is trying to perform some actions based on this stupendous environment, right? So he just wants to go about and get to the flag, right? So he's almost done, yeah. So he's just is trying to learn and try to figure out what he has to do and all of those stuff. And his objective is to sort of come and reach the flag in the optimal possible, in the optimal way, right? So that is what is essentially happening here. Yeah, so that is what is q learning, right? So you're trying to tell this agent to and give him some actions based on telling this agent to take some actions based on the given environment, so that he sort of reaches the ultimate goal. So that's what we're trying to achieve in q learning. And it's called model based learning because it's essentially like back propagation. If you think of in a classical machine learning or deep learning, it's sort of like back propagation where you try to minimize the loss function, right? So that's essentially what it is. And let me get back to my slide. I'm sorry about that. Yeah, so that is what it is, right? So it does not require a model of the environment, and it can handle problems with stochastic transitions and rewards. So what happens here is the transitions that has to be taking place are sort of are the ones, and that the action that has been taken is sort of completely dependent on the rewards, right? So if let's say, if for an example, if you have a dog, and every time he makes a mistake, you sort of scold him bad dog or something, right? So, or you might not give him food, right? So, and if he is a good boy or a girl, you would feed him more food, right? So something, so that's as simple as rewards, right? So in terms of computer, you don't feed any food, but you tell it in terms of numbers, right? So higher the rewards mean more number, less rewards mean, or no rewards mean negative numbers. So essentially, in our example, if we say if the agent is not performing well, then we'll assign a negative one, and if he figures the way out, we just give him a zero. I know, but I kind of feel we have to have a better better uh, rewards in terms of achieving the goal. But yeah, what, why not, right? So zero is still better than -1, right? Yeah, so that is what is the summary and essence of q learning, which is a reinforcement. It's a model free reinforcement learning algorithm. So let's go ahead and see the steps that are required to sort of perform these, take actions kind of stuff. So what are the steps involved in q learning? So initially we start off like this, right? So this is essentially the, like, you can say the flow chart of the q learning algorithm. So we will initialize a q table. So you can think of q table like uh, um, a lookup table as to what the agent must do in a given environment. And I'll talk about that on a later stage, right? So I'm just going to go over this. First, initialize the queue table. Next, choose an action, right? So choose an action as to what to perform. In our case, in that environment which we saw, right, the mountain car, whatever, it had 3 actions, right? So we have to choose any one of the actions, either to go front, go back, or do nothing, right? So these are the kind of different actions available, and we have to sort of choose an action and perform that action. So this step 2 and step 3 sort of go hand in hand, right? So once you choose an action, you have to perform that action, and we have to sort of measure the reward which we get based on the previous action that is performed, right? So like I said, if the agent figures out a way to sort of get to the flag, then it's a positive reward, or you can say a reward is 0. And if he's stuck and not being able to do anything, or trying to figure out a way, sort of doing exploration, exploitation, so all of those things will reward in a negative reward. So we sort of measure the reward based on the action performed, and then finally we update the queue table for the better for a better better optimization. So this is exactly almost like a back propagation where you try to minimize the loss function, right? So based on updating the weights, right? So if you're aware with convolutional neural networks, this is almost the same kind of scenario where you're trying to minimize the loss, right? So that is exactly what is happening here. So let's not waste. I hope you have a fair bit of example as to what Q-learning and the steps involved in Q-learning is. So let's just get started with the the code in Python, right? So this is the normal basic starter code. Yeah, and more about Gym. So Gym is sort of like you can think of it like a open source, uh, you know open source, yeah, reinforcement learning. It's a platform where you can use these environments, and you sort of come up with some the algorithms, right? So if you can check out the documentation, and it's pretty amazing to get started. All you have to do is just install Gym, and you can just get started. And they have different environments. If you go to the environments, right, so you have different multiple environments, and the one which we are using is the mountain car. We'll go over a few other environments, but as of now we are in mountain car, and this is exactly what you gotta give to create the sort of environment, right? So this is exactly what it is. So mountain car. So you can just get started with OpenAI Gym. It's a open source platform to they give you the environment, and you can just start developing your your an agent to reach the goals, right? So something like that. And yeah, so importing Gym, you can just do pip install Gym, and I have already installed it. So it's that simple, and you can just create the Gym. Yeah, and this is like a starter code. It's sort of like a hello world to Gym, right? So something of that sort. Right. So now let's talk about a little more about uh, what exactly is the reward. This env step, so the environment step, which takes in the actions to perform, returns a few items. Those are observation, reward, done, and info. So if you sort of copy this and sort of paste it, although I'm not going to do done, so it might cause I've never seen this to get it to work, but yeah, that's what it is, right? So observation is something like the new state, right? So you can just print. I'm just going to go ahead and print the observation, right? So I'm just going to go ahead and run that, right? So you're trying to sort of print the state that the agent is in, right? So and also for for understanding purpose, let's go ahead and print the reward, right? So and also that. So right. So you can see the reward here. It's always a negative, right? So it's sort of it's -1. So yeah. So once the agent sort of figures out and reaches the flag, we will give him a 0, right? Which is way better than the -1, right? So that is essentially what we have to figure out. So if we go back to the steps involved, right? So if we go back to the steps involved, first is to initialize the Q table, right? So how are we going to sort of do that? So right, so as of now I'm going to stop the video right here, and we'll continue trying to figure out how do we create the Q table, and what exactly is the way to get the Q table figured out, right? So see you next, guys.